Let's go ahead and run the application now, and we'll see all the files got created as part of that process. So what we're going to do now is go ahead and start up the emulator. So I'm just going to go out here to the Android Virtual Device Manager, select that. Choose the emulator we created earlier. Let's just highlight that. Click Start. Now in my case, I'm going to go ahead and say Scale Display to Real Size. Let's go ahead and click Launch, and that'll start the emulator. So here we see my emulator is running on my desktop. I'm going to go ahead and swipe to unlock it. Okay, as that opens up, I'm going to return back here to Eclipse. Just go ahead and close my Virtual Device Manager. So now to go ahead and start the application, I'm just going to go up here to the Debug button. I'll click that, and then I'll go ahead and launch this inside of the emulator. So now we see my application running inside the emulator. It's got my icon that I created, right, my name of my app. So that all worked. Now remember that we're not really interested at this point in what's happening in the emulator. We want to look at the source code and what's involved there. Right, so let's go here, back to Eclipse. And one of the things we'll take a look at here is that there's this GEN folder. Right? This is the generated files folder. Right? If I open that up, you'll notice that it's got a com.pluralsight.demo app, right? Just like my source folder did. In fact, it's actually the same exact hierarchy because it's building it into the same Java package that we're using for our regular source code. Right? So if I expand this out, you can see that the main one we're interested in here is this r.java. Right now, before we take a look inside of there, let's go inside of our regular source code, the code we wrote ourselves. Right, so I'm here, go to my main activity, I'll just double click on that. And remember we talked about the fact that we used this activity main layout resource that was defined here in our resources. We also saw that there was a menu down here called main. And you see also we're using a main as well in our source code. And the thing that's important to notice is that the activity main is inside of a class. It's r.layout.activityMain. My other class for the menu is an r.menu.main. So that's that generated class called R. Now, you'll notice that we're talking about nested classes here. We'll talk a lot more about that later in the series about how Java manages class nesting and so forth. But the thing to note is that if I go inside of r.java, I'll just double click on that. Right, there's my class r.java, and you'll notice that there are class names inside of here that match up with some of the resource folders. Remember we had all those drawable folders. Well, there's a class inside of the R class called drawable. Notice that it's got a member called IC Launcher that matches the name of the icon inside of there. So the system actually matches up this ID with the embedded resources. Right, that same sort of idea is going on with our layouts. Right, inside of our class, there's an embedded class called layout that has a member called activity main that corresponds to that resource. Inside the menu class, there's one called main that corresponds to that resource. So what's happening is that as part of managing and building our project, our Android environment on our desktop is generating this r.java class to have the information that's inside of our resources. Now it's important to remember that you never want to touch this r.java class. You don't want to type inside of here. So you may be wondering, well geez, why are we talking about it so much then? Here's the reason, is that although you never touch the r.java class and it's automatically generated, our code depends on it tremendously. As we go throughout this series, we're going to be doing a ton of stuff with resources. And so that means that everything we do with resources will rely on this generated R class being correct. Now, the overwhelming majority of the time, that R class is correct. It's generated correctly for us. It's maintained for us. In fact, the system just keeps it up to date for us. But you'll find that every once in a while, you'll add a new resource or you'll be working on a resource, and all of a sudden you'll get some compile errors, and you'll notice that they'll have something to do with the R class. Either a member you're trying to use isn't inside of the R class, or somehow what's inside the R class is not matching up to what you expect your resources to have. And what that means is that for some reason, the R class is not being automatically generated for us. Now that happens for only 3 reasons that I know about. One reason is that it's important that you have your project marked for auto build. If I go up here to my project menu, just click on that, you notice that, here there's that build automatically. You want to make sure that that is always checked. That needs to be checked in order for the system to be generating and building the classes as we go. So you always want to make sure that's checked. Now, if you find that you have that checked and your resources are still not matching up, that R class is still not matching up with what you expect, what you do in that case then is do the project and then do a clean. Right? And that forces it to clean out all the intermediate files that are created. So we'll then do a regenerate and a rebuild. Those two scenarios almost always fix it. There's one other scenario that comes up. Is that, remember that when we talked about resources, we said resources make use of a lot of XML files. Well, that means that in order for that R class to get generated, right, the tool that's generating it has to parse through the XML files. The tool is pretty smart, and it can tolerate a fair number of mistakes inside the XML files. But what I have found is that certain mistakes inside of an XML file, or you just do some really bad formatting. Right? In other words, you've got an XML file that's not well formed, or there's something just kind of really mucked up about it. In that case, it will very often prevent the R.Java class from being generated. Now, the good news is that most of the cases when we work with our XML resource files, we're using the editors, the graphical editors, over the XML files. That issue only comes up when we do manual editing of the XML files. Right? So just things to keep in mind. I'll mention those issues again as we go throughout the series because, again, working with resources is so key to what we do. Now, the other thing to take note of is that there's another folder here called the bin folder. And the bin folder is where a lot of our compiled code goes. In fact, if I open that up, you'll see that there's some folders there. There's one for some of the resources that were created, some of the DEX libraries, some of the DEX information that goes on. You notice there's a classes.dex, which is something that came out of that DEX tool. But the main thing that's interesting to us is our demo app.apk. And so this is what gets actually copied out to your device or the emulator to run your application. Now, just as a side note, is that the APK file, as it's set right now, is not signed. Normally, when we deploy for in real life out to Google Play, they have to be signed. We'll talk more about how to do that later. But at this point, that APK file is a Android-ready version of our application that can be put onto a device. It's just not signed for proper distribution. With that, we have everything we've created all the way through the build process. Right? We have our Java classes we created. We have our resources we created. Where we also will have our manifest file that we manage. Right? Then the build process created things like our R.Java that identifies the resources, and ultimately created our application file, our APK file, which is what we distribute out to devices.